Welcome back, guys. I'm Nate and thank you for joining me. Today we're going to be doing a few different experiments using ProtoPutty. In the past, we have showed you how to make your own ProtoPutty and several cool experiments that you can do with it. Today we're going to try out some experiments that a few people have asked about. We've got 4 different things that we're going to try out with our ProtoPutty today. We're going to freeze some in liquid nitrogen, we're going to burn some in our furnace, we're going to try and make a mold using our ProtoPutty, and then we're going to see if we can cast liquid metal in that mold. The purpose of our video today is to run our ProtoPutty through a gauntlet of tests to see how it holds up under different conditions. We have a whole previous video on how to make ProtoPutty, but let's go over the process really quick. We've got here our 3 ingredients that we need for making ProtoPutty: silicone 1 caulking, food coloring, and cornstarch. To get started, let's mix up a few small batches of ProtoPutty that we can use to test freezing and burning. Remember, this stuff smells really strong, so you're going to want to make sure you have a well-ventilated area to mix it up. Remember, when you're working with your ProtoPutty, as soon as it starts to stick to your hands, add more cornstarch. Alright, I've got my first batch of ProtoPutty mixed up. I'm going to split it in 2 and try 2 different things. I'm going to make a ball with one half, and the other half I'm going to spread out into a flat little plank that we can easily dip down into our liquid nitrogen. Now I'm mixing up a second small batch of ProtoPutty, and I'm going to form it into 2 flat sticks to test in our furnace. Alright, now let's mix up a little bit of blue ProtoPutty and try to mold this 3D printed octopus. Doesn't even look blue, it looks black. It'll start looking blue as soon as I mix it. For this octopus, we're just doing a very basic press mold, pushing our ProtoPutty down all over the 3D print to give it a nice even coating. Alright, now we've got a couple of pieces of cured ProtoPutty, and we're going to see what happens when we dip them in liquid nitrogen. You can see that the stuff is very flexible. You can bend it, you can squish it, you can twist it, you can stretch it, and now we're going to see if any of that changes once it freezes. So I'm going to try 2 things. The first is that I'm going to let it sit in the liquid nitrogen until it's good and cold. Then I'm going to take it out and let it thaw, and we'll see if anything has changed. After that, I'm going to take this piece of ProtoPutty, put it back in the liquid nitrogen until it's frozen solid, and then I'm going to see if I can snap it in half. I also have a little ball of ProtoPutty, which is fairly bouncy, and I'm going to see if it's still bouncy after it's been frozen in liquid nitrogen. See, it's boiling as it heats up from the ProtoPutty, but soon it will start all cooling off. Wow, even the part of the ProtoPutty. Okay, that was unexpected. It just shattered from the cold and fell entirely into the cup. Part of it was in the liquid nitrogen, part of it wasn't. While I was just trying to gently stir it around, it popped and broke apart, and then the piece that wasn't in the liquid nitrogen fell down into the liquid nitrogens. Alright, I'm going to pour the liquid nitrogen off into this other cup so I can take those pieces of ProtoPutty out. Oh, that's weird. It sounds like pieces of tile or ceramic in there. You hear that? Alright, let's pour them out. Oh my gosh. Our ProtoPutty has just broken into pieces here. All right, well, I'm doing this out of order, but because I have an extra piece, I'm gonna try snapping this. Yep, just like no resistance at all. That's very weak. It feels about like breaking a piece of chalk. All right, let's let these pieces warm back up and see what happens to them. I'm curious if they'll go back to being flexible and squishy like they were before. Right now, obviously, they're not flexible at all, and they just snap, even if you don't do anything. They just break spontaneously from the cold, which I did not see coming. While we're waiting for those pieces to warm back up, let's drop our ball into the liquid nitrogen and see what happens to it. At this point, I suspect it's going to break into pieces. Bubbles are getting smaller, so the Proto-Putty is cooling down. I wonder if the ball is gonna crack or not. That's a cool effect. The liquid nitrogen fumes flow just barely over the lip of the cup, and then they run down the sides, kind of sticking to it. You can see that the vapors go in with the incline of the cup. All right, I think that's probably as cold as it's gonna get. I heard one little crack sound, but not much else. So let's just pour off the nitrogen and take the ball out, and let's see what's happened to it. Oh, and now it popped in my hand coming out of the nitrogen. I wonder if it's just the heat from my hand or the heat from the air, or just that it was ready to pop and it's just that it's moving now. Well, I was gonna see if it'll bounce. Now I think I'm gonna see if it'll just shatter into a bunch of pieces. Let's try that. Well, actually that still bounced, it just didn't bounce like a bouncy ball. Nothing. It's not really shattering, it's just breaking along the lines where it had already cracked in the liquid nitrogen. So at this point, let's let it warm back up and see what happens to it. They almost look like little gummy candies. They will be gummy, but they aren't candy. Our first piece of Proto-Putty has warmed back up now. Let's see what the texture is like and if it still has the same flexibility that it had before. Well, that tears really easily. Like, it doesn't seem nearly as tough as it was before. Weird. So it tears, and then there's this like white film on the very outside that kind of holds together. The inside just breaks through really easily, but something on the outside, really tough. All right, let's try one of these bigger pieces, see what happens if we break them. Ooh, there's cracks like all through it. I wonder if that's just something else that cracked from the cold and I couldn't see it, but yeah, that stuff, wow. I mean, before I could twist this and pull it and squish it, and now it just is like ripping to pieces immediately. Weird. Whoa, this one's even more broken to pieces. Look at that. Okay, that's not even holding itself together. Okay, these pieces are mostly warmed back up. Let's see if they've got any bounce. They aren't round, so they certainly aren't gonna bounce nice and up and down, but let's see if it will at least have some ricochet to it. That seems kind of bouncy. Kind of like bouncing an eraser maybe. It's not like a bouncy ball, but it definitely has some spring to it. Our octopus mold is ready. Let's peel it off and see how it's turned out. There we go. Ooh, this is looking good. All right, look at that. That did pretty well. You can even see the details of the print lines from the 3D print. As a mold making material, I think this actually works pretty well. It picks up a lot of good detail as long as you make sure to press the Proto-Putty carefully into all of the nooks and crannies. I think if you have any sort of resin or casting plastic, that should work really well in this silicone putty. I do have to warn you, you should not ever use Proto-Putty as a mold for food. There are a lot of chemicals coming off of Proto-Putty that could make your food toxic. In just a minute, we'll fire up the furnace and see if we can cast aluminum in the Proto-Putty mold. We've also got 2 pieces of Proto-Putty we're gonna throw right into the furnace and we'll see what happens. Maybe they'll burn, maybe they'll melt. Okay, our furnace is heating up and starting to melt some aluminum, and while it's getting hot enough, we're going to try dipping in this piece of Proto-Putty to see what happens to it. Before going in, it's nice and flexible just like the other Proto-Putty was. We'll see what happens when it's done. It might just burn up, I don't know. Oh, immediately you see the edges start burning. It starts getting all bubbly. That looks like a badly burned marshmallow. Yeah, that is on fire. That's a cool fire vortex tornado thing going on there. It smells weird, but it almost has the tiniest hint of like a fruity smell, like if you burn a pie. I think that's the acetic acid from the silicone. Now, interestingly, even though this stuff has been burned pretty badly, it's still quite flexible. So burning it, it retains a lot more of its properties than freezing it, apparently. It's a little bit sticky, so maybe it did start melting a little bit as well as burning. I'm gonna see if I can just tear it apart by pulling. Oh, yeah, that still tears pretty easily. So I'd say it did weaken it. Oh, there you go, still red on the inside of the thicker areas. All right, my aluminum is nice and hot. I'm gonna pull out the crucible and then pour the liquid aluminum into our Proto Putty mold. And it's on fire. And it's spilling over the edge, and it's still on fire. The Proto Putty mold is burning. It's still pretty liquid, so I don't really want to get anywhere near it in case it decides to start popping and exploding. Oh, I blew it out and the heat just lit it right back on fire. We poured the liquid aluminum into our Proto Putty mold, and the Proto Putty mold quickly lit on fire. So I think that means that it's not going to be a great mold material for liquid metal. We actually got a little bit of the shape of the octopus's head right there. It's not very clean, it didn't get any of the tentacles, and it did light our mold on fire, but a little bit of octopus head did get cast. There you have it, guys. 4 different experiments with Proto Putty. We've tried freezing it in liquid nitrogen, burning it in a furnace, making a mold out of it, and casting liquid metal into it. We had some mixed results. Freezing the Proto Putty in liquid nitrogen, I thought it was going to freeze, then it would thaw, and it would return to its normal state. But in freezing, it cracked and started breaking into pieces all on its own, and when it had thawed, it was very fragile and didn't hold itself together very well. Burning the Proto Putty did go about as I expected. It just started charring and bubbling and burning. It smelled bad, lit on fire, and in the end it's not really good for anything. It might still be a little bit flexible, but it's also gummy and burned and black, and it smells weirder than normal, and I wouldn't recommend that you burn this for any reason. There's no advantage to it. Making a mold out of Proto Putty I thought worked very well. We got a lot of detail pulled from our 3D printed octopus, and we had a mold that would have worked really well for most kinds of resins. However, pouring molten aluminum into that mold did not work very well. The Proto Putty just lit on fire immediately, and the metal casting didn't come out well at all, so I can't recommend using Proto Putty as a mold for casting metal. Lots of things that we've learned about Proto Putty today. If you've made something cool about Proto Putty, tell me about it down in the comments. I want to know what things you've come up with. Thanks for joining us for this video today, and we'll see you in the next one. Talk to you then. Kind of looks like a giant stick of cinnamon gum. And it's everywhere.
Hey guys, I hope you're having a great day. You are awesome, you are appreciated, and I know everyone over here on my team is really grateful for you. Thanks so much for choosing to watch and support our videos. We'll see you in the next one.